Yep. Our next unit focuses on, at least at the first part of it, what are called complex numbers. We're going to take a deep what are numbers? A complex number, by definition, is any number of the form a plus or minus bi. And this is the same I that we used to solve quadratic equations in our last unit. I is an imaginary number. A complex number combines both real numbers, a real part, and an imaginary part. The a in a plus bi is the real part because it doesn't have the imaginary letter I. It's just a real value. It's just some real number a. Bi, the second part of a complex number, is called the imaginary part because that's where you put the I. That has the I on it. That's the imaginary value part. So what are some complex numbers? For example, -3 plus 2i is a complex number. What's the imaginary part?
-3.
What's the imaginary part?
The part of the I at the end.
Right, so that would be the what part? The 2i. What's the real part? -3. This is a real number. This is an imaginary number. So real part and an imaginary part combine together to make a complex number. A complex number is a combination of real and imaginary numbers. About 1 minus 5i. And 1 is the real part, right? You put the real part first, the imaginary part second. This is the standard form of a complex number. Real part comes first, imaginary part comes second. Is 7i a complex number?
No.
It's not real.
What's the real part? I just see the 7i, I just see the imaginary part. What's the real part? 0. I'm not going to write 0 plus 7i, but it is still a complex number. Its real part would just be 0. 7i is a complex number with a 0 for the real part. I suppose you could also say that -6 is a complex number. It just has the real part, but not the imaginary part. What's the imaginary part for -6? Say it. 0i. Complex number is any combination of real and imaginary numbers. All right. Today's first lesson in complex numbers, I want to focus on powers of I. See if there's a pattern that we can use to simplify powers of I, powers of the imaginary unit I. Gesundheit. So let's start with just I. I'm the first. What was I equal to when we were working with it in solving complex or quadratic equations? Square root of -1. That's how we define I. I is equal to the square root of -1. Let's start looking at powers. I know what I to the first is equal to. How about I squared? I squared would be the square root of -1 times the square root of -1 because it's I times I. Let me write that first, actually. I times I is I squared, so it's the square root of -1 times the square root of -1. What would that be equal to if I take square root of -1 times square root of -1? What's the square root of 2 times the square root of 2? What's the square root of 3 times the square root of 3? So when I multiply square roots, they cancel out, right? What's the square root of -1 times the square root of -1? Why -1 actually? Because it cancels out, right? Everything else cancels out. Root negative 1 times root negative 1 is simply just negative 1. I squared is equal to negative 1. That's kind of weird. An imaginary number squared is equal to a real number. I squared is equal to just negative 1. There is no imaginary part anymore. Okay. I squared is equal to negative 1. How about I to the third?
I times I.
Okay. Could I also call that I squared times I? Sure.
Yeah.
I only said I times I. Well, I'm going to call it I squared times I. When I multiply exponents, I add the powers. I to the first times I to the second is I to the third because there's 3 i's multiplying all together. Well, let's simplify. Let's use what we know about I squared to simplify. What did we show I squared to be equal to? This would be negative 1 for I squared times I. I replace I squared with negative 1. I squared times I is negative 1 times I, or simply just negative I. I cubed is equal to negative I. I'm trying to simplify it as much as possible. I call I cubed I squared times I, which is then just negative 1 times I, or negative I. We'll talk about powers of I. It's going to start collapsing back in on itself. Well, I to the fourth. Okay. I squared times I squared. I also could have done I cubed times I. It doesn't really matter, however you want to break it apart. I to the fourth, there's 4 i's multiplying together, so I times I times I times I. Well, what's I squared equal to that we used earlier? I squared is also negative 1. I can call I squared negative 1. Another I squared is another negative 1. What's negative 1 times negative 1? Here. An imaginary number to the fourth power is really just equal to 1. When I take an even amount of imaginary numbers and multiply them together, I get a real number. Try a few more here. Let's keep going. How about I to the fifth? How can I break apart I to the fifth?
I to the fourth.
One more time, Trey.
I to the fourth, just I.
Sure. I want to rewrite I to the fifth into powers of I already have defined. I to the fifth is I to the fourth with another I put together after that. I to the fourth is really equal to 1. So this is 1 times I, or just I. I to the fifth is really just I to the first. Or I. How about I to the sixth? Do a couple more. Hopefully we start to see a pattern. I to the sixth is equal to what? How about I to the fourth times I to the second? Would that make 6 total i's?
Yeah.
No. When I multiply powers, I add the exponents. 2 and 4 make 6. I've got 6 i's multiplied together. Let's replace I to the fourth and I squared with what they're equal to. I to the fourth we've got defined as 1. So I'll replace I to the fourth with 1. I'll replace I squared with negative. Negative 1 times 1. 1. Haven't I seen that before over here?
Equal to I squared.
I to the sixth is the same as I squared. What do you think I to the seventh and I to the eighth might be?
cubed.
Negative I would be I to the 7th. And I to the 8th would be the same as 1. 1 or I to the 4th. I to the 7th is I to the 5th times I squared. Let's just kind of run through that, make sure we're on the right path. I to the 5th times I to the 2nd. I to the 5th is I. I squared is negative 1. I times negative 1 is negative I, just like we thought it was going to be. I to the 7th matches up with the same as I to the 3rd.
One I.
What do you think I to the 8th is going to be? 1. Wouldn't it just be I to the 4th times I to the 4th? You can break it out however you want to do it. There's one way. You could also do I to the 5th times I to the 3rd. You could do I to the 6th times I to the 2nd. Whatever numbers you want to use to get up to I to the 8th, and then just kind of resubstitute back with how we've defined them earlier. I to the 4th is 1. So 1 times 1, or simply just 1.
Will it always go I, negative 1, negative I, 1?
I love it. It's that same pattern every single time, isn't it? It's always going to fall back to one of the numbers that Shelley just said. I, negative 1, negative I, positive 1. Let's look for other patterns here. If you have an even power of I, what happens? Like I squared, I to the 4th, I to the 6th, I to the 8th. If I have an even power of I, what happens?
It's positive.
I get 1 or negative 1 though, right? I to the 2nd would be negative 1, I to the 4th is positive 1, I to the 6th is negative 1, I to the 8th is positive 1. So any even power of I is always going to be 1 or negative 1. Isn't that just a real number? An even power of I is always a real number. How about an odd power of I? Like I to the 1st, I to the 3rd, I to the 5th, I to the 7th.
And it would be an I or negative.
Either plus or minus I. So an odd power of I is still going to always be imaginary. Even powers become real, odd powers of I stay imaginary. It's always going to follow this pattern. I. Like you said earlier, it's always going to follow this pattern. I, negative 1, negative I, positive. Okay. I have some bigger numbers. What if I want to figure out what I to the 22nd is? You want to sit here and go all the way up and count to 22? Okay. So let's figure out a shortcut to figure out what I to the 22nd would be.
Well, since it's even, it's going to be either 1 or negative 1.
Okay, so I'm somewhere with these numbers. In this chain or sequence of answers, it's either going to be negative 1 or positive 1.
Except for the fact that it's negative 1.
It's got to be negative 1 y.
Because I did count it up to 22.
Okay.
The pattern.
What if I had like I to the 451st?
Oh, well, then I'll be there counting forever.
I know. So let's figure out maybe a way to think about how I could use this chain of answers to figure out where I'm at. Say again? It's a multiple of 2, sure. So 2 divides into it, but 4 doesn't divide into it. So where on this list would I land on? Negative 1.
Oh, that's it? Wait, why?
Why negative 1?
Why?
Does 4 divide into 22 evenly?
No.
So it can't be this one. This number when 4 divides in evenly. Let me just get rid of this.
So it's whatever divided.
Oh, okay.
If 4 divides into the power, you gotta have 1. 4 divides into 22 with what remainder?
Wait, what's the two left?
2. So when the remainder is 2, there's -1. I take the power of 22. I know there's only 4 different possible answers, so let's figure out how many times 4 divides into 22. It divides in with a remainder of 2. It divides in 5 times. So I would count through this pattern. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. I can go through this sequence 5 times, but there's 2 left over, so I can only get out to this number when I have I to the 27. Does that make sense?
Yeah, that's easy.
So we're divided by 4.
Where you're at in this chain, absolutely. Yeah.
So
Couldn't say it better myself, Luke. Divide in 4. Where you're at left over for the remainder tells you where you fall on this chain of answers. I to the 37.
Negative.
I to the 37. Look at the power of 37.
would it be? It'd be.
Oh, it'd be I.
It'd
It was
be
regular I.
Be regular I.
Yeah.
Because 4 divides into 37
9 times.
9 times. How many remainders do we have? 1. If the remainder is 1, you're going to count through this list 9 times, but then you have 1 left over, so you're going to land on this number. When the remainder is 1, you have I. When the remainder is 3, you have negative I.
Ooh, I to 107. Okay.
Sorry.
She didn't calculate.
Why not?
Oh, is it 107?
Yep. I to the 107. What would it be? I agree. Why?
Because it's 26.
4 divides into 107, 20,
6 times.
with how many left over?
3.
3.
The 1.
Count over 3. Because there's 3 left over, and you'll figure out where you land in this chain or sequence of answers.
Try an even bigger number. Oh,
Oh, yeah.
I don't want that one.
Oh,
8 I to the 40th. I first figure out what I to the 40th is, and then multiply it by 8. What's I to the 40th? So 4 divides in 10 times evenly, right?
Yeah, so it'd be, shoot.
4 divides in evenly. So you end up with a 1. This is really just 8 times 1.
Where'd you get the 1?
What's I to the 40th? Does 4 divide in evenly? How?
Yeah.
So when it divides in evenly, you go 1, 2, 3, 4. You land on this number.
Okay.
So it's I to the 40th, I can replace with 1, but then 8 times 1 makes
8.
Let's try a couple more. -2 I to the 15th plus 7 I to the 29th. I, -1, -I, +1. Where in that sequence would I to the 15th land? negative I. I know 4 divides into 15 with the remainder of 3 because it's right before 16, which 4 divides into evenly. So this is negative 2 times negative I.
Okay.
Okay? 7I to the 29th.
It'd just be
That
like
would
that.
It'd be I, yeah. The 7 goes into 29 one time.
Right? So 4 divides into 29 7 times to make 28. Now don't I have one more?
Yeah, so it's I.
I. So plus 7 times I. Can I simplify that any further?
Yes.
I believe so. Aren't they like terms? What's negative 2 times negative I?
Negative, or positive 2.
Positive 2I plus 7 times I, or 7I.
I think 9 squared.
I'm adding, not multiplying. I'm adding. I have 2 I's and 7 I's, so altogether that combines to make 9 I's. Good question. Good question. I'm not multiplying. I am adding, combining those to make my final answer. 9 I. Isn't that kind of weird that it just goes all the way back down to 9 I? Strange. That's it. We'll put a couple more over here.
Here we go.
It's 14.
I can barely see that.
7I to the 14th minus 5I to the 57th. Where would I to the 14th land on this sequence of answers? How many times is 4 divided into 14, and with what left over?
That would be negative 1.
Because there's 2 left over, right? 4 divides into 14 3 times to make 12, but then there's 2 left over. Negative 1. So this is 7 times negative 1.
Oh, I did.
I to the 57th.
Oh, wait.
Just I, right?
That's negative.
Right, so it's a negative 5 times I. I to the 57th. I think 4 divides into 56. Is that right?
Yeah.
4 divides into 56 14 times. So I could go through this chain 14 different times and then land on what number? Or what value? I. There's 1 left over when 4 divides into 57. Can I simplify this any further?
No.
Well, it would be negative 7 minus 5I.
Oh, okay.
Why wouldn't it be negative?
7 times
Negative 1 times 7 makes negative 7. I multiply those two together. Can I combine these any further? I thought someone said maybe negative 12I, for example. Are these like terms that I can combine, like I did down here?
Would it be
Oh, shoot,
positive?
no, they're not.
So all I can do is just write it as the complex number. Real part, imaginary part.
That should be one.
That's just it, right? Why can't I go any further? They're not like terms.
Nice.
All right, here's one more for you guys to try. Let's finish up with this.
This all that we're doing today. Just
For
this-
today, yep. And I have some focus areas. That'll work.
Is that
9I to the 100th, Eric, minus 6I to the 46th. I left that sequence up in blue. Use it to figure out how you can simplify I to the 100th and I to the 46th. Nine I to the 100th minus 6I to the 46th. There, Trent. You're looking for the answer. There it is.
Oh, 10 times suffers 2 eyes. 4 goes into 46.
11 times.
11 times.
With what remainder?
Left over.
Remainder 2 means you're going to land on what number? Yep. So I to the 46, I can substitute in negative 1 for.
6 times 1.
That's right.
I to the 100th is 4 divided into 100 on my.
Okay.
I to the 100th is just 1.
I got 1 deep.
So instead of 9 times I, it's 9 times 1.
Okay, so minus 6 times.
9 plus 6, 9 times 1 plus 6 makes 1.
That's all we can do.
9 plus 1 is 10.
9 times 1. 9 times 1.
Okay, minus or plus 6.
But it's negative 6 times negative 1.
Yeah, that's what I'm trying to say. So
This shouldn't be right. It should be 9 times 1. I to the 100th is 1. Doesn't 4 divided evenly to 125 times?
oh yeah.
So when 4 divides it evenly to your power, it's going to reduce all the way down to 1. I can go through this chain 25 times, and then all of a sudden I land on 1 when I get up to 100.
So if it divides it evenly, it's always 1.
Yes.
Oh yeah, I'm really good with that.
So this is really just 9 times 1
Which is
minus 6 times what?
6 times negative 1.
Negative what?
Negative 1.
Negative 1. I to the 46 has a remainder of 2. When I divided 4, so that's negative 1. 9 times 1 is 9. Negative 6 times negative 1 is positive 6 because of the double negative. Altogether, there's the 15 we should have for our answer.
I got 3.
You did 9 minus 6. Don't forget the double negative in there. Minus 6 times negative 1, that's 9 minus negative 6, or 9 plus 6, which
Yeah,
makes
this
15.
Can we do one more on the board?
I have some more practice here for you. How about we do some of that? You try. I put a packet of some complex practice that we'll need to hang on to for the next week or so as we make our way through complex numbers. We're not doing all of it now. We're just doing some of it. Why don't you grab your laptops too? Put together the practice for the complex numbers portion of our next unit. Could you grab your laptops? I'm going to show you